Hey everyone, and welcome to another session of CeerazzleDazzlePhysics. In today's session, we're going to be talking about atoms and isotopes, guys. So this is in GCSE Physics, and put down today's title, it's going to be Atoms and Isotopes. So we'll scroll down and get started with today's lesson. So here is the nuclear model of the atom. Maybe you've seen this in other subjects such as chemistry. It's the same thing in physics. So here we have the central part of the atom. It consists of two different particles here. Well, they are both located in the nucleus. So this is the nucleus of the atom. Somebody asks you what is the nucleus of the atom? It's this part over here. There are things which are orbiting around the nucleus. These things are called electrons. So the electrons are over here. And they are orbiting around in these things called electron shells. So they are electron shells. Sometimes you might refer to it as energy levels. So energy levels over here. So they're in these actual things going round and round and round. So what are the actual particles themselves? So we're going to say the red one is going to stand for a proton. So these are protons. The blue one is going to be neutrons. And obviously we already defined the cross, the green cross, that green cross over there, that's going to be the electrons. So the charge of the proton is +1. The charge of a neutron is going to be 0. If you ever forget that, remember that protons are positive and therefore +1. Neutrons, think of the word neutral, therefore 0 charge. And last of all, electrons are going to have a negative charge of -1 over here. So -1. What about the masses of them? So the protons have a relative mass of 1, neutron also has a relative mass of 1, and electron has a relative mass of 1 over 1,800. Happy days. Make sure that you're familiar with this table, guys, because many questions are asked based upon the characteristics of these particles. Okay, so now let's talk about nuclear notation. So let's scroll down and look at the following. Here we have helium. So helium has 2 protons, 2 neutrons, and 2 electrons. But I can actually use a notation to describe helium from now on. So helium, we can use the notation of He. So these are the chemical symbols. If you look at the periodic table, they will have the chemical symbol of He. And it has a top number and a bottom number. The top number is 4. The bottom number is 2. This whole thing over here can help me describe what it looks like. Okay? Now I'm going to explain how. So the top number over here, this top number, this is the mass number. So this is the mass number. The bottom one, this is the atomic number. So this one is the atomic number. So what is the atomic number? The atomic number is simply the number of protons. So the atomic number is the number of protons. And the top number, the mass number, this is the number of protons and neutrons combined. Protons and neutrons combined. There we go. So the mass number is the number of protons and neutrons. The atomic number is just the number of protons. Wonderful stuff. Now, using this notation, we can then obviously work out the number of protons and neutrons. So we said the bottom number is the number of protons. Therefore, I have 2 protons, which is true. Look, I've got 2 red protons over there. And to work out the number of neutrons, we can do something quite nice here. To work out the number of neutrons, you take the mass number and you subtract the atomic number. So if I do 4 minus 2, therefore it will be equal to 2 neutrons. So you have 2 neutrons present. Have a look. So look, we've got 2 neutrons present, 2 of the blue ones over there. So we've got 2 neutrons right now, and we have 2 protons. Wonderful stuff. So look, we can get 2 protons. The reason why, I just look at the atomic number, and I take the mass number and I subtract the atomic number, and that will give me the number of neutrons. So let's summarize it below. There we go. So now, as you can see, I've put it all down at the bottom. To work out the number of neutrons, I simply take the mass number and I subtract the atomic number, and that will tell me the number of neutrons. Because look, guys, I did the 4 minus 2, therefore I've got 2 neutrons over here. Okay, so the next thing you might be asking is, well, how do I know the number of electrons? Well, I know there's 2 electrons here, and the reason why is because usually the atomic number is the number of protons, which is also the number of electrons if the atom is neutrally charged. There we go, it's the number of electrons if the atom is neutrally charged. So I knew there was 2 protons, which therefore means there are also 2 electrons, only if the atom is neutrally charged. Excellent, so now we understand how nuclear notation works with the mass number and an atomic number. Let's move on, everyone. So, test your understanding. What does 16.8 oxygen look like? Well, what does it look like and how many neutrons does it have? Well, first of all, we can draw it out. It looks like the following. Here we go, guys. It looks like the following. Make sure you understand the reason why. Because now look, I've got how many protons? 1, 2, 3, 4, 5, 6, 7, 8. Why? Because look, the bottom number is 8. So therefore, yes, you're right, 8 times by proton. How many neutrons do I have? Well, I can quickly work that out. I simply do top number minus the bottom number. So therefore, 16 minus 8 equals 8. So I've got 8 neutrons. So 8 protons over here and 8 neutrons. And I got the 8 neutrons by doing top number minus the bottom number. 16 minus 8, therefore, is equal to 8 neutrons. So what does it look like? We've done that. And how many neutrons does it have? Well, we know it's going to be 8 neutrons in this case. Wonderful stuff. So we've done these two questions to test our understanding. Okay, so moving on. What are isotopes? So what actually are isotopes? Well, look here, guys. I've got 3 versions of carbon. Carbon 12, carbon 13, and carbon 14. They are all carbon. Why? Because they have the same atomic number. The atomic number is key to keeping it the same element. So they're all going to be carbon. Carbon 12, carbon 13, and carbon 14. And look, guys, I've drawn them out already. So we've drawn them out already. I'm going to give you a second just to look at them, and I want you to try and identify what is the difference. What is the difference between them? Right, so let's quickly do the following. Let's look at the number of protons and neutrons in each one. 1, 2, 3, 4, 5, 6. I've got 6 times protons here, and neutrons 1, 2, 3, 4, 5, 6. I've got 6 times neutrons in this one here. What about carbon 13? I've also got 1, 2, 3, 4, 5, 6. 6 times by the protons, and I've got 1, 2, 3, 4, 5, 6, 7 times by the neutron here. Okay, next one, we've got 6 protons again. Count it carefully, and look, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 neutrons over here. So these are all isotopes. So these are isotopes, guys. The reason why is because look, they have the same number of protons but a different number of neutrons. And that is the key definition for isotopes. Isotopes have the same number of protons but a different number of neutrons, guys. And that's a definition you should memorize. Atoms which have the same number of protons but a different number of neutrons. Okay, so moving on. Electron transitions and radiation. So the other bit that you need to know about GCSE physics, and this is in the higher tier of the course, is going to be how do electrons move up a level? How can they move up a level? Well, they can move up a level in the following method. So here we have helium once again, and an electron can move up to this level over here if it can absorb some radiation. So if radiation comes in, there we go, radiation comes in, the electron can absorb it and move upwards, and it will end up looking like the following. Here we go. So as you can see, the electron moves upwards because it absorbs the radiation, and therefore it can move upwards over here. So there we go, I'll put on the right hand side, electrons can move to a higher energy level by absorbing radiation. That's the key thing here, it can be absorbing the radiation, moving up to a higher energy level. So now what you're thinking next, what about the reverse? What about if an electron tries to move down a level? What can happen then? Well, we can do the following. So we know that in order to move up, I need to absorb radiation. Well, then to move down, I've got to simply emit radiation. So this electron can drop down to here, and it can do so by releasing the radiation, releasing a bit of radiation over here. And therefore, it can drop down. So it looks like the following. There we go. So as you can see, the electron has dropped down, radiation is emitted, and look, the electron has now moved downwards, down to that energy level here. So, summarizing, electrons can move to a lower energy level by emitting radiation. Okay, and that's it for today. Let's have a quick recap right from the top. So from the top, atoms and isotopes. I introduced you to the nuclear model. I defined the nucleus being the center of it and electrons orbiting around in electron shells or energy levels. Protons have a charge of +1, the mass of 1. Neutrons have a charge of 0 and a mass of 1. Electrons have a charge of -1 and a mass of 1/1800. Scrolling down, we have nuclear notation. Nuclear notation, we said the top number corresponds to the mass number, which is the number of protons and neutrons. The bottom number is going to be the proton number, which is the number of protons. To work out the number of neutrons, when you're given the notation, you simply take the top number and you minus the bottom number. So 4 minus 2 is equal to 2 neutrons here. And there we go, I've summarized it all at the bottom of this page here. And look, we drew it out here. We know it's 4 and 2. Why? Because it's 4 in the nucleus in total, and 2 is going to be the number of protons here. Then scrolling down, we tested our understanding. I gave you oxygen 16.8 and told you to draw it. We drew it out and worked out the number of neutrons. Easy stuff. Last of all, I talked about isotopes. So isotopes are going to be different versions of the same element. As we can see, carbon 12, carbon 13, carbon 14, which have the same number of protons but a different number of neutrons. They have the same number of protons but a different number of neutrons. That's the reason why it goes from 12 to 13 to 14. And then scrolling down, we talked about electron transitions and radiation. We know that for an electron to move up at energy level, radiation comes in, and it will look like the following. It pumps up a level. Yes, and obviously in order for an electron to move down, it has to emit radiation. So yes, it emits radiation, dropping it down a level over here. And that's it for another session in CeerazzleDazzlePhysics. Make sure you like and subscribe to keep my channel going. And last joke of the day is going to be, don't trust atoms because they make up everything. Ciao, ciao, and goodbye.